Hey everybody, thanks so much for joining me this evening on Houdini Hangout. My name's Peter. I will be putting together some Houdini stuff tonight, hopefully some interesting Vellum grains simulations um, that was suggested by Crossfader on our Discord channel. And so got kind of a framework to go with. The the idea was to kind of have, well, let me see if I can just pull it up real quick and show everybody that. Just kind of see what we were trying to target. Let's see here. Yep. Okay, that's weird. Let's just mess something up. So this is kind of the idea that we're going for, just something with some grains flowing around and maybe doing some some interesting looking stuff like this. Um, yeah, so that's the idea. Um, we're gonna try for something like that. We'll see what happens. But yeah, I was playing around with it a little bit yesterday just to kind of see if I understood the concept completely, and seems to be making good sense. So we are going to try to do that here. All right, so let's jump in and do some stuff. So let's first grab a geometry node, and I'm going to load in file from disk. I have some electronics that I had downloaded before. Let's see here. Models. Thing, that's right. Yep. Was working on this on my other computer, so. Okay, so I think what I'm going to grab is, let's see here. I could actually try these. See what these look like. They'd kind of be interesting. Some headphones. Sure, why not? Let's give it a shot. Okay, so we are going to. First of all, I'm going to set this like on the ground plane. So let's do that. Let's do a transform. Do that. That match size. That's gonna bring us to the ground plane here. And if needed, we could obviously offset it a little bit if we wanted to go below the ground plane or above it. Cool. Okay, so I'm just gonna do a null there. Say out. So we'll just say geo Oh, and before I get going any further, just a reminder as always, like I'd love, if you guys have any suggestions, any thoughts about how to make, um, how to make what we're working on, or anything that I can do better, anything that you think maybe I'm thinking about it the wrong way, or you have another suggestion on how to look at something, please drop it in the chat. I'd love to hear from you guys. I'd love to know if you have any suggestions on how to do things better, how to, just anything you might think about working in Houdini, because I don't want this just to be me telling you how to do something. I'd love for it to be something where we're kind of learning, talking back and forth, just having, being able to kind of learn together, because I've learned quite a bit from doing this as well. So yeah, so hopefully you'll feel so inclined to drop some messages in chat, and we can talk about what's going on. So yeah, I mean, I'm definitely not, an expert on Houdini. I've been using it for quite a few years. I do a bunch of training, but I'm always learning more things. I don't know everything about Houdini, and yeah, probably never will. So anyway, so yeah, if you feel like you want to contribute to the conversation, please drop it in chat. I'd love to hear from anybody. So as I was talking, I was kind of thinking about this, and I actually feel like this isn't going to work super great. So let's just try something else here real quick. I'm going to go back and grab this camera instead. Let's see what that gets us. Okay. So I don't know if I even need to put it to 0. Yeah, I don't. I'm just going to reset that. Yeah, I think this will make for a little bit more interesting shape, and we won't have to deal with the inside of that like headphone arc. The other thing I'm going to do is, this is gigantic, and I meant to do this before. I'm going to scale this to fit, and then it's going to be really tiny. So let's do it like that. Yeah, that should be good. Something like that. Cool. All right, so we'll say instead camera, and then geometry here, and we're going to say and so what I'm going to do is I'm going to make box for where the grains are going to live, so we can source from this box. And let's do this. I think it was something like that. That'll be good. Yeah, that'll give us a pretty good amount of grain real estate. And so I'm going to do that. And let's do the size. All right, I'm going to use this again just to sit it on the ground plane, because when we do the grains, we're going to set a ground plane just at the XY plane. So, or I'm sorry, XZ plane. So there's where our grains are going to be in the scene. So there'll just be a little bit there, and then they'll kind of stack up as and fall as they as like the simulation starts. So what I'm going to do is I'm also going to merge, just say camera, to target, oops, that one here. We're going to target this out, bring this in, and I'm just going to say VDB from polygons. Now this doesn't need to be super accurate, that's why I'm doing it this way. I just kind of basically just going to cut this out of the ground so that it's not putting putting grain inside of this geometry to begin with. So let's set this to, I don't know. Yeah, that's good. Just something like that. It's not a ton of voxels. You can see here it's about 20,000 voxels, which is basically nothing, but it'll be enough to give us an idea of what this shape is. So we'll just say, no, we don't need to name that. We know what that is. And then I'm also going to do a VDB from polygons on this. And then I'm just going to do an SDF subtract. For these, click the first one. It should connect them both in. And there we go. The other thing I could do here too is I could copy this parameter, and I could paste the relative reference there. So if I changed this, for example, they would both change. So we can do that. It really doesn't matter. We can probably do it at 2. It would be just fine. Cool. So I'm just going to Shift L to just kind of arrange that a little bit. And yeah, so then we can just do a convert B. Oh, in fact, you know what? We might be able to just do the Vellum grains right from this. So let's see, Vellum grains, because it does. Let's see. Not sure if it'll work from this or not. Too bad. I was hoping it might do it that way, but it won't. That's fine. Convert ADB. There we go. So we're going to convert this back to a polygon. Just really light. I don't want to have a ton of geometry, so I'm going to turn the additivity up a little bit here. And we can set this to something like that. Great. Just needs to be a basic representation of the shape, just so we're not getting any intersection here. And in fact, what we could even do is we could do SDF reshape, I believe. And I'm just going to dilate it by 1, and that should be good. What that's doing basically is eating away at this a little bit more, just so that it doesn't get too close to the camera. So let's just hit L. Oops. That was in the window. Shift L. Great. And now if we come down here, still don't have grain. Oh, I wonder if it was just that the particle size was too small. Or too big. Let's try this again. Hey, cool. Okay. Forget you. We don't need you. Great. That makes sense anyways. Great. So we can now dial this in and get the grain size that we want. I don't know. Let's see. Let's see if we get a couple layers here. Maybe we do one more. Let's see if we can get a couple more here. Yeah, that looks good. About 500,000 particles. I think that's perfectly fine. Let's just ghost our camera here. We can see that we're getting a little separation there. That's good. Hey, Zach, how's it going? Glad to have you on the stream this evening. Nice to see you. Well, technically I can't see you, but you know what I mean. So yeah, so obviously if you wanted to tweak the distance there, we could set this. This is in voxels, so you could set this to 3 or something like that, and it'll go 3 voxels out. So yeah, maybe that's a little bit better, so we're not getting it underneath the lens. You know, you can kind of play around with that as you like. But anyways, there we go. Okay, cool. So we've got this working here. So let's. Well, hopefully you learn some cool tricks. That's the goal here, right? Let's see, Vellum solver. So I'm going to drop a Vellum solver down here. And for those of you that are sort of new to this stuff, the first connection here is the geometry stream. The next one is the constraints, and then the final one are any collisions. So we're not actually putting anything in for collisions here, so that won't actually do anything here. There won't be any collisions coming through. But the constraints or properties that get made on that, we can look here. We can see what constraints are being made, and actually there's not even any constraints being made because we're not connecting anything specifically one to another. So in this case, we're really just creating the grains, but it's a good kind of habit to be in to connect all 3 of those anyways. So, all right, great. So here we're on the Vellum solver. I'm just going to turn the ground position on. That's just adding in a ground plane for us. You can obviously see here we can change its position or where it shows up. Now this is infinite in all directions, but in this case, you know, we basically would just bring it up or down. So obviously if we brought it down a little bit, you know, it would fall and hit the ground, but we just want to keep it right at 0 so that they'll just stay the way they are. So let's just hit play real quick. We'll see what happens here. But these should kind of fall, sort themselves out a little bit, and you'll see that they're just kind of sliding all over the place and going crazy. And that's not what we want. We don't want that. So, actually, probably a few too many particles here. I'm just going to change that to 0.25 and see. Yeah, that's fine. The first thing that I'm going to play around with here is this, some of our frictions. I found that if you bring this dynamic scale up a little bit, it'll help it kind of settle into a little bit of a better beginning state here. It doesn't tend to just go flying off forever. Another thing that really helps our substeps which I probably will turn up at least to 2 when we get a little further here. You can see how much cleaner that looks already. But obviously we get a little bit of a hit in performance, and it's so similar with 1. It's a little different, but not by a ton. So for me, I'm just going to leave it at 1 for right now. And then at the end, when I'm like ready to get something looking real nice, I'll turn the main substeps up. Just so this is kind of just like my working, situation here. I'm getting like 6 frames a second here, and yeah, so it's a lot better for me, I feel, to work in this way, and then we can always kind of go from there and figure out what, what it's going to look like after the fact. So I'm going to turn off. Well, actually, for right now, that's fine. So, the one thing we could do here too is we could get this set up. So I have this reshape. I'm just going to say dilate SDF so we know what that side is doing. So here we've got this VDB from polygons, and if we bring this in and look at our, where would it be? Collisions. Oh, I guess I'm thinking of the volume, or the pyro. What am I thinking of? Oh yeah, the pyro sim that's in SOPs that actually has a different way of bringing in a VDB for collisions. So what I could do here is I should actually be able to just bring this right over here. We can have this set up for collisions as well. So now if we look at it, yep, we're seeing that as a collision object. That looks good. Let's hit play, see if anything bumps into it. Yeah, looks like it is. Great. Okay, cool. So now we're piping that collision through. We've got the Vellum solver here. That's all looking really good. So if you remember maybe from a previous time that I've worked with Vellum, if you dive inside, there's this thing called a dive target inside of some of the newer SOP-based dynamics, things like that. Hi, how's it going, Mammoth? Thanks for being on the stream today. So this dive target is actually a couple levels in from our actual geometry level. You can see here sim grains, that's our node right here. And then as we dive inside, we actually skip 2 entire levels and go right to this subnetwork called forces. So that's where we're in right now. Obviously, if we clicked on one of these, it's going to show us a kind of locked out version of what the DOP network is doing. Or we could come here and see this crazy network. And this is all the HDA that was developed by the folks over at Side Effects to just kind of wrap a DOP network and make it so that you can interact with it right from SOPs without having to deal with going to and from DOPs. So they kind of do all that hard work for you, and then you can just add forces in and things like that. So anyways, just something to know if you're maybe a little new to this. But so here we can add in forces, and on this side we can add in sources. That rhymes, which is funny, but whatever. So here's a little note that tells you where things go, if you're wondering. So what I'm going to do real quick is grab a pop force. I'm going to do pop wind. Oops. Yeah. And I'm going to drop this onto the force output. And so from here, we should see, so if I do my amplitude to maybe like 5 or something like that, what we should see is this start to swirl around. So let's take a look here. Sure enough, we got some crazy particles flying around. That's actually way too much. Let's do 2.5. Cool. So this is how we can add in forces to this grain simulation, right? So this is adding in a wind, basically. We can turn the air resistance down up here. So if we turn this down, we'll see that there's less movement. It's only in the really high velocity areas where things are actually going to get swirled around. If we bring this to maybe 0.6, we'll start to see a little bit more of it. And this is just random, forces that are getting kind of pushed through here. We've got this noise that we're adding in here. You can see that there's swirl size, swirl scale, So we could scale it in different axes. We've got pulse length, which just means how quickly is it going to change. Roughness, which is kind of how much difference there is from kind of one place to another in your noise field. And attenuation, I never really feel like I totally understand attenuation. But then turbulence is basically how many levels of noise are kind of, layered on top of each other, finer and finer levels of noise. So let's take a look at doing something like changing the swirl size. So if we change this to something really big, like 5, you'll see that there's kind of these big currents that are going to come through here. You're not going to see little elements moving. You're just going to see these really big kind of sections that are moving around. If we go something smaller, this is going to be really noisy. It's going to almost be like just random noise in there, and each particle is almost moving in their own direction. So, we might want to go somewhere in between. The reason I keep jumping back to the beginning is just to make sure it kind of picks up those parameters that I've set and go back, kind of restart caching through the simulation. So yeah, I'm guessing we're probably going to want to be somewhere in this 0.5, maybe it's going to be 0.75, something like that, where it's going to give us a little bit of noise, but we don't want it to be too crazy. We don't want it to be too noisy in just big sections. So we'll play around with that, but I just wanted you to see how that works specifically. So kind of going back to that graphic that we were talking about earlier, the idea was that there were kind of these concentric circles around the geometry. And so I was kind of trying to play around with how exactly we might do that. And I think the way that I find to be pretty helpful is that we could actually use some geometry to kind of hold the value of how far the camera is to a given point in space. In this case, what I'm going to do is I'm going to put a grid down. So let's do another grid. But that's okay. I'm going to make this the same size just so it fits to the, actually it's going to be 5, nope, it's going to be 7 by 5. So that should be good. I'm just going to make sure that I can see these and make sure they're matching up. Yep, so you can see all my points are kind of templated. That's what this little pink flag means. It basically means just show me kind of a hint of where those are, kind of a ghosted view of where those are. Okay, so we've got our grid. I am going to, let's see here. So this is going to be the rows, and that is in this 5 axis here. So I'm going to copy this parameter. I'm going to paste relative references like that. I'm going to copy this parameter and paste relative references. And then, so now at this point, as we scale the size, the rows will follow exactly. But we want to have kind of like a multiplier here. So what I'm going to do is I'm going to right click and go to Edit Parameter Interface. It's a little bit maybe more technical, but I think it's a cool thing to learn how to do. So we're going to grab the separator and drop it in here. That'll just make it a little cleaner for us. If we hit Apply, you'll see it's now added a separator. And I am going to grab an integer, drop this in here. I'm going to call this, I don't know, maybe grid molt. I'm just grid multiplier, like that. And I'm going to set a range for it. So let's do 0 to, or actually, we don't want to do 0 because that doesn't work. We're going to do 1 to 100. We'll hit Apply, Accept. So now we've got this grid multiplier attribute right here. And in fact, I am going to make sure that where's the defaults? Oh yes, we're going to lock it that way. And here we should be able to set the default to 1. Okay, cool. Apply, Accept, great. So what I'm going to do now is I'm going to take these relative references, basically, or these references, and multiply them by this. So I'm going to copy this parameter, paste the relative references to that, And there we go. Great. So I'm going to just copy this here. Apply that. That. Great. So now I have a multiplier that'll allow me to, oh, I'm going to untemplate this just so you can see better what's going on here. So now I've got a multiplier that'll allow me to change the resolution of my grid. So it's a simple little thing, but it does help quite a bit. And what I'm going to do is on this grid, I'm going to store the values of how far they are to the surface of this geometry. So let's do that. So here, let's keep it to about 50. That should be probably more than enough. So there's that. And what I'm going to do is I'm also going to, I'm going to move it over here. And I'm going to use a transform to, what? Cool. Great. Weird. I don't know why that crashed. All right, let's try it again. It should be saved. I can load it in a second. Sorry about that. Give me a moment to reboot here. It's a rare one, I feel like, for me. I've never seen that one happen. Let's see, open crash file. There we go. And I'm going to save this as like that. Okay, we're back. What I meant to say was we're going to take this transform and I am just going to move this down so that the center of, like, because I want this shape to be kind of represented, not this bottom shape here, which is just the kind of body. It's not going to kind of grab this lens as well. So let's just take this and kind of slide it down. I'm also going to hide other objects. And yeah, we could actually maybe turn this grid on just so we can see that. Maybe like that. That should be good. Great. Okay, so we've got this and it's intersecting this grid. And so let's do a distance from geometry. And so what we're going to use is we're going to use this grid and we're going to grab this attribute there, and that is coming from the transform. And now we're going to get the distance from the geometry. So we're taking the grid and calculating how far we are from this transformed version of this camera. So at this point, we're getting a distance attribute. That's kind of a fun mix of words, output attribute. And if we turn this on, we can see, sure enough, we're starting to get, we're getting a distance attribute based on, how far we are from this camera. So at this point, we're looking pretty good. What I'm going to do is a couple little tricks just to get us the minimum and maximum values here so we can refit this, because I want this to be a 0 to 1 value. So let me show you kind of a neat, I think this is kind of cool. If you don't have Labs, go download it immediately. It's so good. Side Effects Labs, fantastic. If you use the launcher, you can, I think you can get it from there, or can you get it from the launcher? Not sure, let me see. Yes, you can get Labs here, so you could install Labs if you wanted to from there. Or you could get it from Shelves, Side Effects Labs, and then if you don't have it installed, this update toolset will be all that's in there. And you click that and a little dialog pops up and you can install. So anyways, Side Effects Labs is awesome. So a lot of good game dev stuff, but also a lot of really cool tools. So I'm just going to type min, and there's a Labs. What? Something's funky with my... Not happy. Weird. Sorry, guys. My Houdini is acting all wacky tonight. Let me try it again. That specific node was, let's see, this weird error. Oh, that must be it. It decided to just not install Labs. Well, here you go. You can watch me install it again now. Okay, update. Sorry about that. I don't understand why this happened. Great. Yep. So the Side Effects Labs toolkit is really nice because it's kind of these, it was kind of these experiments. I feel like that started within some of the devs at Side Effects, especially the game dev folks. And okay, so we got that now. Cool. So it's really neat because I feel like they started with just game dev, and then they started just making tools and like all these different things that they were like, these seem really helpful. And now there's like a million different tools. So I think if you were doing any of the Mardini stuff this past year, um, you should have remembered that there was a few labs tools in there. So anyways, if you haven't used labs before, go check it out. Okay, so this is a really nice tool because all it's going to do for me, which it really is pretty simple, but I can do a couple things at the same time. So I'm going to do a minimum here and a maximum. And we're going to use a point attribute, and the attribute we're going to use is dist. And so what this is doing is it's going to find the minimum distance and the maximum distance here, and we're going to be able to use that to refit this distance attribute to like a 0 to 1 range, and that'll be helpful for ramping our parameters in a second. You'll see how that becomes helpful for us. But okay, so we've got the minimum, maximum, average here. So the next thing we want to do is get this this attribute to be able to be kind of controlled in a little bit of more of a in a specific way. We want to be able to kind of make rings based on distance to the actual model. So let's mess around with that and see what we can get. So actually, that's kind of strange. It seems like there's some weird distance stuff going on there, just in this crevice. Anyways, so I'm going to do a point photo. This. And let's go in here, and we're going to need a ramp parameter for sure. And this is going to be a spline ramp. I'll call this and so let's bind in an attribute called the attribute dist. And we are going to need to fit that, right? So we're going to fit the range. We're going to fit that here. So the distance is going to go into the value of this fit. And here you can see that this has a source minimum, source maximum, destination minimum, destination maximum. So there's 4 different options that you can put in there. And so what we're going to use is we're going to grab a detail for detail attribute. And what we're going to look for is the first input. It's going to be a float, and it's going to be, we'll do min distance, like that. And then I'll make another one. This one max distance. And from here, we can just put these into the source minimum and the source maximum, like that. So now this fit range, if we were to, let's do a bind export, and that's going to bring an attribute out of here. it's going to write an attribute out. So now if we take this fit value and look at it, we can see, I'm going to call this, let's call this active, because these are going to be the active regions for like our noise and our color and things moving around. So we've got this active attribute. So I'm going to go in here. Actually, I'm going to go up a level. I'm going to pull out the info panel here and do active. And so this should look more or less the same. And the reason for that is that these attributes are both auto-fitting their ranges right here. So if we did distance and did minimum maximum 0 and 1, it should change the way that it looks, and I think I'm on active, so that's why. So there's distance, great. So that's actually the 0 to 1 distance right there. Once this gets full red, that's the distance of 1, and then 0 is where it's fully blue. So if we look at, let's see if we go to active, set this as active there, turn that off. Same thing here with the active. We want this to be minimum and maximum, but now you can see that that goes all the way to the outside here. So now 0 is the minimum value, which is actually inside of the camera itself, because we actually measured inside as well, but that's fine. We can tweak that in a second. And then the outside, the maximum here is this distance, and that's up to 1. And so the reason that that's helpful is because now when we take the 0 to 1 output from this fit node here, and we put it into this ring control, if I throw this in between here, what this RAM parameter is looking for is a 0 to 1 input, and then it's going to give you a 0 to 1 output. So this is basically like a lookup with this control ramp right here, right? So what it's doing is it's looking up from the 0 value all the way up to 1, and then we're mapping this. This is like the incoming value here, and we're mapping this outgoing value based on that. So like if we were going to look at the distance, in this case the distance of 0.2, and we wanted that to be stronger, we could bring this all the way up here. We could bring this maybe in a little bit like this, and then this last one, if we make this like a spike and do it like this, you can see now that at a distance of 0.2, we're going to have our strongest area right there, kind of at this distance of 0.2. So it might be a little hard to see just because we've got these multiple colors. That's kind of a little confusing. So let's just change the visualization mode just so we can see this a little bit better. So I'm just going to change the color here. I think I'm going to change it to white to red just so we can see it. And actually, you know what? I liked the blue color. We're using that anyway, so we'll just start looking at this blue color. So there is our 0 to 1, our 0.2 value kind of focused right here. So we can obviously narrow this in, have it a smaller little band like that. You know, we can do this and then tweak. We can use this ramp to kind of tweak how this is going to look. So we could do another spike here if we wanted to, right? And then we'd have a second ring outside there, and maybe we want one that's a little closer here, like so. And so this is going to make different rings kind of around this geometry. And so we can click and then shift click, and that'll allow us to move these around. And so like this, we can just kind of tweak these around, put them where we want them. Unfortunately, we don't have a good, not that I know of, I haven't found a way to like scale these together. I wish there was like a way to like kind of, I think Cinema actually has a pretty nice way of doing, tweaking their ramps, but you know, you can't win them all, I guess. So, yeah, so you can obviously play around with this however you would want it to be. You know, maybe it's something like that. I don't know. We can just kind of leave it like that for right now. But so this is now, these could be considered like our active regions that we want to be having an influence within the grain simulation, right? So we need to bring that attribute into our simulation somehow, right? And you know, you might think, at least you know from the start, you might think that maybe you would take this this attribute and write it onto the grains, right? Like you, before they come in, write this attribute to it. But the problem there that I found, and I don't really think there's an easy way to get around this, is that it's going to write that attribute specifically to a number, like a grain with an ID number. So it's going to write it to a very specific grain particle. So if you want it to be, moving around, or if you want this effect to be happening in this location and not to a specific, and then when the particles blow away and maybe some new ones fall back here, you want it to be updated. Well, it's really still going to be connected to that other particle that flew away that you wrote that attribute to from the very beginning of the simulation. So we want this to update constantly while we're simming, to keep looking at this, saying what's in this area, what particles are there, and how do we, how are we able to, how can we, what is the section, what particles are in this active region. So we're going to need to do that actually inside of this Vellum solver, or at least that's the way that I found was the easiest to do it. There's, again, always a million ways to do everything, but so I'm just going to say set active region. And cool. All right, so we've got this. I'm also going to null and just say maybe activity, active, yeah, sure, active. And that's just going to give me a nice easy place to pull from. So we've got these rings on this geometry, right? And so when we come to this Vellum solver here, we want to go inside of here and have there be some sort of connection between that, right? So let's go inside here again, right? So when we're inside of this forces, this forces dive target, excuse me one second, I'm just going to take a quick drink. Hopefully everybody's following along. Anybody got any questions? You can drop them in chat. I'd love to hear. If you're like, no, we're good, that's awesome. But just, please feel free to jump in, make comments at any point. Let me know if I'm doing something ridiculous, etc., etc. So glad to have you guys with us. And anybody that's watching after the fact, you can always reach out on Twitter, Houdini Hangout. And we have a Discord that I started not too long ago, so you can go in there and ask questions and whatever. So anyways, all right, so we're inside of this, this forces dive target. And if you look up here in the top right, you can see that this is a dynamics context. So we're in DOPS right now. Yeah, for sure. You could use a modulo to animate them. Yeah, of course. I mean, the cool thing with this is that anything that as we start building this system up, you'll see how you can kind of tweak anything you might want to do with this. So like, just for an example, like if you wanted to have regions maybe that were like turning on and off or something like that, you wanted to animate them or modulo them or whatever, you could actually just have one, you could have like multiple rings if you wanted to that you're like controlling. So if you did something like adding in another ring here, you could actually take this and go like this, and we could add these together and make sure that so then here I'm going to do a lamp and do this. So I'm just clamping it to make sure it doesn't go over one if I accidentally had something go over top of it, right? And then let's do one more thing here. Let's do a multiply here and here. Hey, let go. And what we can do here is we can promote this parameter. And this does basically the same thing as this parameters. If you look, it's kind of really similar. You just click on that little nub. And here we'll say ring 1. If say 8, 1. And I'm going to do the same thing here. Middle click, promote parameter. And this one is going to be 2. Oh no. Orient, wow. 6 a.m. and you haven't slept? Jeez. Are you working today? Or are you a late night, an overnight worker or something, man? Whew, that is crazy. So, so what we could actually do here is we could change these to integers actually, and have these go between 0 and 1. Just for now. I mean, you could have them as floats as well, but I'm going to change this to integer 0, 1. Cool. Okay, great. So that'll be like an on-off switch kind of a thing. And then we could have, oh, I know, this ring control ramp is actually set the same, unfortunately. So I'll say this is ring control 1, and then this is ring control 2. And that should update properly. There we go. So now we've got two different. Oh no, working as a freelancer. Yeah, with an inverted time zone. I had that happen to me when I was in college. I just was such a. We had labs that we could work in overnight, and I had a key to them because I was a lab monitor, and I would be in there so late at night, and yeah, after a while it was like 6 a.m. and I'd be going home, like you said, to go to sleep, and then I would go to sleep and wake up at like 6 p.m. and be like, oh, I guess my time has just completely switched. This is horrible. So anyways, okay, so what we could do here is we could just kind of tweak this interface a little bit. So what I'm going to do is just take this down here to the bottom, and actually, you know what, I'll put these at the top of each of them. So these, I'm just rearranging where those parameters are in the interface. And I'm going to put a separator in. Oh, no, actually that's fine. Those are separate enough. So I'm just going to hit apply, accept. There we go. So now we have activate ring 1. Yeah, I'm going to put a separator there. Maybe a spacer. I don't know what the difference is between a separator and a spacer. Let's see. Let's see what the difference is. Huh. Okay, well, gives us a little space, whatever. So at this point now, we have two different like ring positions that we could have, right? So we could set a ring there, and then yes, I usually do. Well, I usually stream a little bit earlier. I had some internet issues tonight. I have internet issues from time to time, but yeah, I usually stream at 8 p.m. Eastern time. So I don't know what time zone you're in or whatnot, but yeah, I usually stream at this time. So there's that ring and that ring. So, you know, at this point, you could turn these on and off, right? So, Zach, I know you were saying about the modulo. So you could then set each of these to have some sort of modulo effect, right? And set those to turn them on and off at that point. So that would be something you could do as well. Kind of an interesting little trick. The other thing you could do as well is you could just straight up animate it. That would work as well. And if you did a float instead of an integer, you could possibly, the way I'm doing this, it's not going to work exactly with a float, but there is the opportunity to adjust how much velocity you're inputting into these particles by changing the float, right, from 0 to 1. So you could kind of slowly ramp it up and down over a few frames or something. But the way we're going to do it is just going to be kind of more of a like a fully active type thing. So, all right, I'm just going to move this in a little bit, something like that maybe. Oops. Yeah, of course, man. Yeah, that's why we're here. Ask questions, see what we can do. I'm going to make these a little bit narrower just so we get a little bit better of a how they feel here. And yeah, so obviously we could do this as many times as we wanted to and get this interface working. There's also like really cool new twirl down options. I don't think the Vellum solver has it. Oh, yeah, it kind of does. These like twirl downs. That would be something I would probably do is like if I was going to actually like take time and make a nice interface, I would put these as like twirl downs so that you know, it's a little cleaner. But so you can see here, obviously we're making these separate parameters, and they can add in here. And So they are going to merge together, but they're never going to go past one. So that's kind of nice. They'll make these, whoops, they'll make, so you can kind of almost merge them together there, make some interesting stuff. So anyways, I'm just tweaking this like crazy. All right, maybe put that there. And I don't know, maybe I'll just make another one up here. Just using this scale so I can see where they're at. Maybe. Oh. Something like that. Cool. All right. So we've got our couple rings, and this is actually the two outer, the in and out one, and then this one there. So anyways, you could do this. You could have 20 rings if you wanted to. You could do all sorts of stuff with it, but just something to see. And that is a cool option to kind of bring up anyways. Okay, so now let's talk about how we could bring this into our simulation and actually start to affect those points. So if we come into our Vellum solver here, like I was saying, we're in the dynamics context. So we can't just do something like a attribute transfer, right? Because that doesn't exist here. Oh, thanks. Well, I'm glad you can join. I actually don't know. I'm not familiar with John Coons. I'll have to check out his check his stuff out. Interesting. But yeah, no, I'm really glad you found the channel, and yeah, there's a bunch of stuff on here that I've streamed, and I don't really ever go back and edit it or anything like that. So there's stuff of me screwing around. Sometimes it works out great, sometimes it doesn't. But hey, that's life. So we can't just do an attribute transfer in here like we might want to maybe in SOPs. So in DOPS, it's a little bit different. What we're going to need to do is figure out a way to actually kind of almost create our own attribute transfer. But for me, the best way to kind of go about doing this is either by pretty much anything pop will work in here, right? These are all these pop nodes are going to work. So the ones that I'm going to lean on here the one specifically is the VOP, but just know that there's also a pop wrangle as well. And so I'm going to use the pop VOP, which is kind of a mouthful. But so we're going to use this to kind of find that attribute and bring it into here. And the kind of key to working with something like this VOP, especially in a situation like this where it's kind of like levels deep inside of this node, and we don't have really any access to an input node here either, so we can't just like wire this in somewhere because these things are going other places and we don't really have control over that. So what we can do on this pop VOP and as well on the pop wrangle, if I can type, is this inputs tab. And so on my pop VOP, I'm going to go to the inputs, and input 2, you can see we've got a bunch of different stuff here. So DOP data would be something in the DOP network that we could pull in. Myself would just be whatever stream of data we're talking about here. In this case, the data bindings tell us that it's the geometry data, which if we look in our geometry spreadsheet, we have a Vellum object right now that we're working on because we're working in Vellum, and we see that there's geometry right here. And so these are all the point positions and all the attributes that are going along with it. Right, so this is everything that's happening in DOPS right here. These are all the attributes that are getting saved and used in DOPS. So if we want it, so that data binding is basically saying the same as this myself. That's basically whatever this data is. That's what we're working on. So this isn't really like a point wrangle or a primitive wrangle or whatever. It's like a DOP wrangle in a way. It's a little different in that sense where in this case is going to be working on points, but depending on what you were using, you might have different types of geometry that you're working on. So it's kind of an interesting situation here, right? Where you don't really have we don't have what's the name of the Discord? If you go to, here, I'll give you the website. I have an invite list on there. Right there, there's the link to our website, and there's an invite on there as well, so you can just go on there and join the Discord. There's actually a way to be able to chat right from there if you want to, and yeah, there's a bunch of other stuff in there, suggestions for what we can stream and things like that. So yeah, please please check out our website and Discord, and our links to YouTube and Twitch and everything are on there, depending on if you were like, oh, I'd really rather watch this on YouTube for this in your instance. So anyway, so this pop-up is a little different. Same thing with the Wrangle. They're both like that, where there's not really the option to say, hey, work on points, work on this. We're really more talking about this data binding of this geometry that's coming in here. So anyways, long story short, inputs. So we can do a bunch of things. We could use the first, second, third, fourth input, but none of those we have access to. So luckily we have this SOP option. And so let's grab that. And you'll see here that there's a ton of nodes that we didn't create. These are all things that are coming under this Vellum solver. There's a ton of nodes in here, and there's you can see there's a crazy amount of stuff in here. Awesome, yeah, no problem. And so here's the active that we set up. It's up a couple levels, and we'll just hit accept. And so now the second input is reading that active node that we made up here. So this is now coming into our, oops, wrong one. This is coming into our DOP network, into the second input of this pop VOP. So let's go inside here and let's do this. So right now we're going to be operating over points because we just have points. We don't have anything else in here. If we look at our geometry here, we don't have any vertices, we don't have any primitives or polygons, and we have some detail attributes, but it's not going to operate on those. So let's do a near point lookup. And if you've never done this before, it's pretty simple. You just use the input here, and you can just point that to op input 2, which is the second context input. And then we'll use the position from the actual point position, which is this P. So that's now getting our near point attribute. So what I'm going to do is just do a bind export, and honestly, I'm just going to do something just as a temporary thing, just to see what we're getting. And so it's right in my, oops, right at the beginning. I'm just going to throw a couple A's in there. And we can see, okay, we're getting some stuff going on here, although I'm not seeing any near points there, which is a little odd. Oh, I know why, because we got to go to the next. It doesn't calculate on the first frame. That's why. We might be able to turn that on. Hold on, let me see. There is an option often for calculate on first frame. It may not, let me change this real quick. Not be something that we can easily do in this because this is set up kind of for us. We don't have access to that specifically in here. So yeah, I don't think we'll have that, but that's okay. If you were doing this from scratch in DOPS, you'd have an option to calculate on the first frame. So, keep that in mind. Okay, so we're getting this attribute right here is being written here, and it's the nearest point on this grid. So we know that we're getting points. The near points, they show up as integers. Looks good. So then we can do a point attribute. Great. So we know that this is the point number we want to look up. We want to look it up from the second input right here. And the attribute we want to look up is active. And this is a float. So now instead, let's just check that out and see what we can find here. Just go back, let this recook. Sure enough, we've got some values coming in there. So that's looking good as well. This should be a 0 to 1 range. Sure enough, it is. I mean, we're not getting technically all the way to 1, but pretty darn close. So that is working really nicely. Excuse me. And so from there, now what do we do with this attribute in order to make this work? So the way that I kind of felt that this was going to be really helpful or work really well is by setting a group that this is going to work on. Because if you look at this pop wind right here, we can actually set a group that this is going to be active on. So pretty much I feel like the easiest way that we can do that is by taking this result here, doing a compare, and we're going to put the result into the first one. That's meaning it's comparing it to that, and we're going to say greater than, and let's do it to, I don't know, 0.5 or 6 or something, just about halfway. That's going to output a bool attribute. We can look here. And from there, let's see, we could actually go Okay, so we're comparing it here. If it is greater than 0.6, it'll be a 1. If it's less, it'll be a 0. So let's go back up here and take a look at this. We should have that coming out now. We sure enough do. And there we go. So now we have these attributes that are set, right? And so instead of doing it just as an attribute, though, what we want to do is set it as a group. And that's really a very similar process. So here we've got this compare. We're not going to use this bind export. What we're going to do is set attribute. And you might not have seen this before, but we can actually set point groups in here. So we're going to set a point group, and we're going to call this, let's just call it active. Maybe capitalize it just to make it a little more obvious that it's something different. And this would be an integer attribute because if you look at the end here, your groups are integers right here. You can see it's group Steam. If you're doing this in Vex, you can actually just write at group underscore and then the name of your group, and that'll set it if it's an integer attribute. So it's just something to keep in mind as well. So here we're going to take this Boolean value, stick it right into the value here. We are going to take this top of these two i's. This is looking, if you look at the bottom there, it says pointer primitive number. We know that the point number that we want to get is the point number from our geometry, so that's what's coming in here. And we're going to take this and put it over here. I'm just going to shift this down a little bit so we can see the network a little bit better. Great. And so now this is setting our points point group, and you can see here we now have a group active. Whether or not that's being set or anything, oh, there are some that are being set to that. Cool. And this is actually really easy to visualize here as well. I'm going to turn this visualizer off, and we can use this guide, and we can go to points, and we can see there's our active points right there. And so this is going to be a live update, and we can use that to kind of control what's going on in our simulation. So now, if we take this and we set this group to active, we're going to see that this is only going to be active in those areas right there. Be a little tough to see like that. Let me just maybe kick this up a little bit. So let me change this, I don't know, maybe a 4. Also, it's kind of hard to see with them just white. So since it's a little tricky to see with them just white, let's make that nice as well. So here, if we have a compare coming out, right, that's a 0 or a 1, so we know this is a true or false. So what we can do is we can do a two-way switch, and this is going to use this same condition, and we can just set a couple constants here. So I'm just going to do a constant just to set color here. So let's set this color. We'll set this to white, or no, sorry, this will be blue. And if we change it here, this could be white. And then from there, we'll take our geometry outputs and just put this into CD, because that's our diffuse color diffuse. And let's hide this because we don't want to see all the groups. And I think we can actually watch it from here. We should see the color. Sure enough, there's the color. And as they leave this region, they're not going to be colored anymore, right? So the unfortunate thing here is that this is cooking on every frame, it's recalculating on every frame, and it's pushing those particles around, and we're really not getting to see, you know, we're not really being able to follow those particles and what they're doing. They're just kind of like, we see the rings, we see where the activity is happening, but from that point, we're not really seeing, you know, we're not really, it's rewriting the white or the blue every frame. So that's we're like, okay, we're getting kind of close to something, but we're still missing a little bit. So let's just kind of take a look at what this looks like in real time. So we're getting something. We're getting these points to really activate in just those sections, and they're moving around and stuff. But we want to be able to tweak this a little more, maybe. So instead of having this just be on all the time, let's first do another. Let's try something else here. Let's do enable solver. And this might not seem like this would be something that would work because really, are these solvers? I mean, I guess they are. But in this case, really what this is doing is more or less enabling this stream of data. So in DOPS, everything goes from top to bottom, left to right. So that's just the order of which they're calculated. So it's calculating the pop vop, then the pop wind, then the enable solver. So actually, I'm going to say so let's do let's actually do one of those modulo functions here in this enable solver. So here we're going to do I'll just say $F modulo. I don't know. I was doing it before at 24. Maybe I'll do it at 18. And then I'll say equals 0. So a modulo is basically just the remainder. So it's doing a division and from basically looping from, I don't know, how's the best way to explain that? It's dividing it, it's taking the frame number and dividing it by 18 and only returning the remainder. And if the remainder is 0, this will evaluate as 1. So right now it's evaluating as 0, so nothing's going to happen. We get to frame 18, it's going to pulse for a frame, and then we're going to get, again, same thing in a few seconds here. Yep, just like that. And so what you'll see happening here is that it's going, actually, you know what, it's 2 weak now. So let's up this a little bit. It's 5, something like that. So every 18 seconds, we're going to get a pulse of this kicking in, basically. So what's happening here is it's rewriting it's keeping the point positions throughout the whole simulation. So it's getting more and more like rough and mixed up and stuff, but it's resetting the color. So it's putting in these random movements to the particles and kind of pushing them around, but it's not you're not seeing I guess how to explain it. It's because it's pulsing frame by every 18 frames. We're only seeing it. We're seeing it reset because it's writing it to blue at that frame, right? So pretty much what we need to be doing is we could do something a little bit different here and allow it to maybe fade out, or actually set this up a little higher so it's not so noisy. I think it'll be a little more interesting if we can actually see it do something. Yep. Okay, so this is enabling or disabling that this stream here every frame. But what we could do is we could do a merge. This will work pretty similarly to how a merge would work in SOPs. And then we can actually do another pop over here. And from this, I'll get rid of this pop wrangle, we don't need that. From this, we can just do a real simple, we can just say fade color. And so now we'll do a color mix. And what we're going to do is take the CD as the primary. Secondary will be another constant. And that we'll just do as white again. And then we can put the color into here. And I'm just going to mostly bias this towards the original one. So the original CD being the top one. So let's go back up here. And this should, now on every frame, not only, or on every 18th frame, it should pulse in that blue and then slowly fade it out. And so that's maybe a little bit more of an interesting effect from that standpoint. Now, another thing that I was kind of thinking of is like, what would it look like to have, a ring of particles that are going to start in the center, possibly, and then, move outwards, right? So like maybe they start towards the thing and go out across, the geometry there. So here's what it looks like here. So we've got this like little pulsing thing going on here with like color and all that kind of stuff. So that's, again, this isn't exactly the same as what was happening in that other video that we watched, and there's certainly other layers that we could add into this as well. But we're starting to source in attributes. We're starting to get color in there. Another thing that could be done in order to make the color stick around would be to set like an attribute that says like that when it gets activated, right, it sets an attribute of 1 or something like that, or puts it in a group that was like previously active. And so we could actually have we could keep that active group all the time and not overwrite it based on if sorry, I'm just trying to think. So not using this active group here for the wind to set the color, but use a different group there. Like maybe that's like a color group or something like that. And that gets set and then it gets kept and it doesn't get reset again every time. It just is basically getting added to. And I actually, now that I'm thinking of it, I wonder if we could do that here. I wonder if we could add to it. Let's try it. Actually, now that I'm thinking of it, let's give it a shot. Not sure if it'll work or not, but we can try. No. Oh, you know what? I'm gonna turn off this so it doesn't fade them out. Yep, it might work. Ah, no, it didn't. All right, well, I'll have to figure that one out a little bit more as we go. But that's one option there. So now let's look at what it would be if we had like a moving kind of area here. So yeah, let's make another one of these here. And I'll say this is like this for animated. Let's set region. And so what we could do here, there's a few different ways I guess that we could look at this, but let's take this. All right, let's just tweak this a little bit. So instead of having 2 of these, we won't need this. Let's just do 1. And we can get rid of this. Clamp, we won't need. The multiply, we probably won't need either. Great. So we've got our ramp control here. And if we go up, I'm going to just set this to a default, which is like basically the hill here. And I'll just set this to be, we can just leave it like that. That's fine. So at this point, if we're looking at these, this grid and we set it to active, we should see just like that, we've got a faded area like this. So what we can do instead is we can actually take this minimum distance and the maximum distance, and we can make some offsets to this to this range basically. So what we can do is, let me just think about this, add here, and if we took this, let me just show you this with an add constant. As we take this add constant and move it around, you can see that this is actually moving where this ramp starts. Now it can't really go past the end attribute or the end value here because that's being set by this second import detail here. But what we could do there in order to kind of control that is we could multiply that if we wanted to. Oops. To constant. And we could scale that down as well. So this would give us, you know, that multiplier there, and then this will allow us to kind of change the inner area. Now, obviously, if we go past it, it's going to invert and go the other way. So there's some things that we could possibly tweak there as well. The other thing that we could do is we could take the output of this here, which we know is a 0 to 1, and we could just offset that. So what we could do is add another fit in here and take something like this. And I'm going to make sure we don't have that internal thing there actually. So let's just add constant. I'm just going to give it a little padding here. Basically what I'm doing here is just setting it so that it's it's kind of expanded past that negative value. So that's not inside of where this camera would sit. So we added just a little bit there just to kind of push it out a little bit from those negative values. So from here, we can now adjust this, right? We could use this to kind of create the area that we're going to look at here. And if we wanted to, what we could do here is, oh, it's different. All right, I'm not thinking about this. So what I'm going to do is I'm going to add another parameter in here and give this a float value. Separator in here, so let's see the difference. Kind of doing a lot of parameter editing here. Oop, change the label of it. We'll call this and so what we're going to use this for is to add onto this source minimum here. So let's say we'll just do it 0.1 to start with, and we'll take this value here, this top value here, we'll copy this parameter, paste the relative reference, and then copy this parameter, add that in here. So now these are always going to be this distance apart from each other, right? So we can control how wide this effect is going to be. So maybe it's 0.1. And then as we slide this through, it's going to move out so we can animate this, right? And if we go inside of here, you know, if we go negative, basically go backwards, we're going to go inside. So let's, yep, that should be good. So now what we can do is we can promote this parameter because you really don't want to animate in here. So we're going to promote this, and we're going to say, we could say effect. Oops. Let's just call this effect position. That. So now when we come up top here, we we have this effect position, and we can, oh, wait a second, I might have done the wrong one. Oh, you know what? I think it's not pulling it because this is grayed out now. Yeah, that's why. Okay, so what I'm going to need to do is have it actually look at that other attribute here. So I'm just going to copy that parameter, go inside of here, and do that right here. Paste relative references. There we go. So now that'll follow along. So we could just simply take this and keyframe it to here, and do this to, I don't know, do 1, I guess. It should go. Not liking. 9. But that's okay. All right. Well, instead of doing that, let's just edit this. We'll just do that up at the top level then. No big deal. So source max will that as well. There's something I didn't really think about how that would work, but that's okay. Like that. Great. And then from here, we should be able to now just copy this parameter, paste a relative reference. Now it's the same as it was when it was inside. And I'm just going to add one more parameter here, and we should be able to go with this. So let's call this width. And I can do the same thing I did before, copy this parameter, add it to that, and we'll put 0.1 like this. And now we've got it. Great. Why that wasn't working before, I don't know. It seemed like it should have, but I know VOPs don't really always love for you to have animated stuff inside of them, so, which makes sense, but I don't know why that was particularly being considered animated, because it was animated up at this level, but hey, whatever. I guess I don't make the rules. All right, so we've got this animated section here, and so what we should be able to do is we can change this around a little bit. So let's grab these, and we're not going to use this enable solver, so let's just do this. And just change this down a little bit. So we'll do Hello, do you have me now, hopefully? I will wait for your responses. Hopefully that's a yes. Okay, perfect. Hey, yay. Man, I swear, this stuff just doesn't want to work for me sometimes. So, I'm just looking at this, and it's such a weird situation. Ha, thank you, Crossfader. Welcome to the stream as well, for you. Um, yeah, so this is really strange. I feel like it should be. I feel like it's like updating later or something. It's just really, really interesting how long it's taking for these um, to be kind of moving around and stuff like that. The other thing that we could do here is instead of using a pop wind, um, we could, let's see here, this pop velocity. Just for an example, we could do something like this. Throw this in here instead. Sorry, this is becoming a little messy, but um, so that's working. Why the wind takes so long? I don't. Oh, I know why. Because it's the. Yeah, I think I know why actually. Because of the air resistance. I think if I turned that up to one, I think that'll actually. Yeah. So, um, yeah. So what so what we could do a couple. I mean, we could do a bunch of different things here, but we can use this activity to kind of drive any part of it. Because right now, obviously, we've got the activity right there going where it's going to be causing those whatever's in that area to get a velocity, to move around, do whatever. So let's see. Let's see if we change this to something smaller. How does this work? Great. Let's Interesting. Huh. That's that is it's really bizarre. Oh, I think I know why. Because if I do this, I bet you it won't do that. Maybe. Sorry. Troubleshooting in real time. There we go. I think that's right. Yep. 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 So there we go. That's doing something a little bit more the way we might want it to. I'm just trying to think of the best way to maybe set this color here. Um, yeah, the other way you could do it too um, would be to kind of build that, instead of using something like this wind or the velocity, which is much easier because it's kind of a built-in, um, it's a built-in node that has like a lot of stuff in it. Actually, I kind of wish this velocity had the noise that the SOP velocity has, which is kind of silly. I don't know why they wouldn't have that in here, but I mean, obviously you could put noise in here with the expression. Yeah. Anyways, but what I would do if I was like really trying to dig in deep to this is instead of no problem, man. Yeah, get some sleep. Don't stay up all night. Good luck with your switching times. So with the pop vop, you would, instead of trying to do the activity as an integer, like I was saying, and driving a group here, you could take this activity here. So yeah, let's look at how that works. So let's just do a bind export here. So we can bind export from this and call this active, right? And if we look at this attribute, in fact, I'm going to turn this off. I don't want this to be writing. It's over here. Anyways, I can grab it. So if we looked at this while it's going, I think we might see that attribute maybe. No, we're not. Why are we not seeing that? Oh, maybe because, yeah, because we're in. Yeah, there it is right there. Let me just turn off this velocity. We don't need to see that. So if we look at this now, you'll see that this is actually like a fading attribute here, right? And we could obviously adjust that based on the ramps that we have set up. Like here, for example, like if we wanted to change the activity width, we could do that here, and that's going to change how far that width is going, basically, right? So that would, and this ramp here is going to control it as well, right? So if we did it like that, oops. I don't know. Anyways, so if we did it like that, instead of using any of these things here, let's get rid of this pop velocity and this. So we're setting, we'll say set active attribute instead. What? Oh, maybe just, oh, weird. I realize that's what that would do. So then if instead we did something like another one and use this to set up, just say, that. So now if we bind in, this is obviously a more complicated way of doing it, so this is why I wasn't doing this originally. So we do active here to bring that in, and then if we do do a noise of some sort, turbulent noise, I think it's fine. Yeah, that'll be fine. Just do a 3D noise. The position will be the point position. Oops. The active will set the amplitude, and then everything else go as is. And then we'll do maybe we will do like a mix to mix them together. That way we can kind of bias it towards one or the other. Let's do that. I'll put the blend into V. So this is basically taking the turbulence noise and then blending it into the original velocity, because we don't want to just set the original velocity. We want to kind of like modify it to some extent, so it doesn't just like it. So it isn't doing some weird like hard overwrite. I mean, you could just add it together if you wanted to. We could, you know, there's a bunch of different things, but this is kind of like quasi-averaging it or doing stuff like that. So just with the bias as well. So let's just play around with it, see if this works. But this should do something more or less what we're looking for. So let's look at this. Oh, we've got to remix this active because let's do a fit range. And let's do 0 to 1 and set the destination 0 to 5. I don't know, something like that. There we go. And so now we should start to see that. Where are we at? Oh, there we go. It's weird. I wonder why those sprites are going away. It's easier to see before. Now it's like not showing us those sprites anymore. It's really strange. I don't know why that happened. Oh, it's a visualization. That's fine. So here we go. So you can see that that's obviously pushing it around as well. We probably need to tweak that a little bit to get some better noise in there. Oh, right, that's alligator noise. Let's do simplex. That's probably better. Sure, let's give that a shot. Yeah, it's not too bad. It's not like super complicated. It's just a different way of thinking it, right? Because you're using that attribute as like a multiplier. The other thing that we could do is instead of using this turbulent noise, we could just do a vector instead. Let's see here. Trying to think of the best way to do that. So, well, let me just do a constant for now. And I'll do this as a vector. Set this to be 1. And then what we could do is we could multiply this by a parameter. And this should be a vector as well. And we'll just call this, or no, actually that should be a float. Yeah, float. And we'll just say scale. And what this will do is we can use this as like our up vector basically and multiply stuff by it. Then we could, let's see here, we'll take this, just trying to organize this so it makes more sense. So we'll take this and we'll just this noise would still be affected by collision and gravity because it's being, yes, exactly. This is all happening in DOPS. All of this vex is all happening in DOPS, and that's why this stuff is all working the way it is. It still has the collision, still has the gravity, still has everything like that built in because we're working within that Vellum solver. This is all happening in the Vellum solver. So yes, exactly. So I've got the multiply. We're going to add in this turbulent noise. So maybe we don't quite need to have this so high. Maybe we'll set this to like 5, maybe. Oh, in fact, you know what? I'm going to do this as like -1 to 1. Oh no, sorry. I'm thinking of the noise. Losing it a little. Starting to lose the brain. Okay, so this should make simplex noise. Cool. Maybe there might be a better noise for that, whatever. So what that should do now is give us an up vector basically here and then we're going to scale that and then add the noise into it. So let's change this vector scale to like, see what 1 does, see where we get from there. So no, this should be a smoother way of like having that ripple go. Yep, sure enough. Excuse me, what? Why are we floating upwards? Need something? Excuse me for 1 second. My wife is needing something. Hold on 1 second. All right. Sorry about that. All of my wife's art supplies and things are behind me right now, and there's a green, like a green fabric back here. It doesn't. I'm actually doing this as a green screen, but anyways. Okay, why on earth is that just going up? Okay, I guess. Hmm. Must be missing something here. I think what I need to do. Yeah, that's clearly not working. Right, because I'm just setting its velocity. That's right. That's why. Yeah, that doesn't work, does it? Maybe if I put this into force, maybe that's what I'm doing wrong. Sorry, guys. Let me try this again. Certainly is interesting looking. It doesn't seem to be doing what I want it to do, but we're doing something weird. Oh man, I think this thing's drunk. I think I ruined it. I don't know what I did here. Okay, some noise. Here, you know what I'm going to do? Instead of doing this as a fit, I'm just going to. Oh, that's the problem. I gotta multiply this in here as well. I don't want it to. Ay, ay, that was just so stupid. the up vector needs to get multiplied with the noises or with the scale, the activity region, because that doesn't work otherwise. Whoops. Oh yeah, guess somebody's getting tired. All right, let me look at that again, because I was just doing that so stupid. So yeah, I want to use the activity to multiply this as well. So this is scaling the vector, and then this is scaling it based on where it is in the scene. So yeah, that way I'm not being total dummy. All right, let's just do this here. I'm gonna just do stand in here and just maybe turn this noise down just a bit. See how that looks. Yeah, I'd say that's doing more of what we were hoping for it to do. Yep. Yeah, I'd say that's a little bit closer. The color thing is a little weird. I'm just trying to think about how to best do that, because that's like almost like it's like an accumulation type thing. I'd like for it to like get set and then fade out. Maybe what I could do here is sorry, just thinking here for a second. So yeah, colors are maybe a little different. Maybe I could just do it with a float and then look it up after the fact. That actually might be smarter. Might be too late for me to think through this one. Hmm. Well, are there any other questions that you guys have about what I've been doing here with this simulation, um, and how I was kind of getting this to work? The other thing too, I guess, that we could look at as well is how well. In fact, we could just switch this over here and just see the original again, anyways. So yeah, anybody have any questions about this or any thoughts, comments, ideas? The look isn't quite as good as what the previous one was, but the concepts are there. I just would have to dial it in a little bit more. The other thing I was thinking was to do something where I took the geometry like of basically of the camera, like this like a split of the camera geometry here, and like basically just boolean it with the ground, and have it so that the different rings would be like attraction sites, and expand those out, and then have like the particles like attract to it, and then when they're done attracting, they would like let go. That's another thing I was kind of thinking that I could do. What exact process of that is? That might, if we're interested in something like that, I could possibly try to do that next week. The rings are based on distance, so if the camera was rotating, the rings would react. No, the rings are based on the distance here between this camera and the grid. So the camera is stuck through the grid here, and that right there, it's figuring the distance from any point on here to this surface of this geometry. And I believe it's the closest surface of the geometry, unfortunately. So from there, so that distance looks like, should look like that. Hello? Oh, there we go. So that is the distance right there. And in fact, I think I changed that. So I'll just click this to auto. So there you go. There's the distance based on the distance from a point on this grid to the camera. And then in these attribute VOPs here, this is where we were setting those active regions. So if we turn this on, we can see the activity regions that we made. So here, this animates through, right? And so it's using the distance, it's looking it up through this, through these ramps. Here, we were using these ramps, and we have controls that we could click them on and off if we wanted to, right? So those are looking at the distance and then setting the active regions based on these ramps that I set up. So so no, if you rotate the camera, it doesn't change at all. It's not distance based by camera or anything like that. It's not screen distance or anything like that. It's completely linked to this ground plane. And so that ground, that like grid that I set up is basically like it's kind of like an intermediate for storing that distance and then looking it back up in the Vellum grains. Because otherwise you'd have to be doing you'd have to do some more VEX or VOPS work to get those distances in DOPS. So here we just have this really nice distance from geometry thing that we can just literally, you know, we can just set this up super easily, and it'll do all of the calculations for us. So, you know, we can do distance from surface, outside of geometry, whatever metric we're looking for here. So, yeah, if the camera was animated, it's not gonna, like, so if I threw a camera in here, right, and oops, if I threw a camera in here like this. Oh, you're talking about that camera. I forgot that I put a camera in there. Yes, the rings would react. Yes, exactly. I'm sorry. Can you tell it's 10:45? Yes, you're 100% correct. Somehow I forgot that we had a camera in this scene because I had it hidden. Yes, 100%. So yes, if we rotate this camera, let's see here. Well, yeah, I'll just do it. I'll just do this camera. So if we took this camera and rotate it, didn't change because of how I had this. So yes, 100% this would all calculate through. And instead of looking at that, let's look at the distance here. Just remap that just so we can see it maybe a little bit better. And yeah, so as we change this camera geometry, update. And then if we look at this and set this to active area instead, bingo. I got there eventually, man. Whew. Yeah, for sure. Yeah, you could animate the camera, have it, update like that. Um, Another thing to consider with that as well is that this is going to be lighter, the lighter that this geometry is as well. So, you might want to change the grid here because I just was kind of arbitrarily doing that. I haven't really like optimized this in any way, but this should actually work a little bit smoother, I would think. Yeah, this should update maybe a little faster. So if you reduce obviously the resolution of that grid that's holding those values, there's less values that it has to calculate and do all this distance from geometry and then setting the active region. It has less to do basically. So, um, something to consider there as well. And yeah, if you did this even right, and you had the camera animating, for example, did it from 0 to here. That should update, and you should see that. It's a little slow. Not the fastest thing in the world. Because we're recalculating that on every frame. So if that was the case and the geometry was moving, I might go more with a lookup um, that would calculate in like vex or vops the distance from every point to the camera, for example. That might be easier to do. It might be faster to do because that would be doing one calculation every frame. In this case, I was just kind of going the easiest way and the most like simple way to do this possible. But in that case, if you had moving geometry that needed to recalculate, you might be better off doing it that way. I can't say for sure, but yeah. So it's definitely possible. But and obviously, if you had a shape that was maybe more interesting, it might work better. The hardest thing is the further you get away, the more the shape gets blurred, obviously. So it's really tough to keep the shape of that object consistent. Like even if you did something like, well, heck, let's change this out because we were looking originally at the what was it? There's something else. Headphones. Let's see what that looks like. Try that out real quick. It's the beauty of Houdini, right? A little bit. Doesn't like that. I wonder if this geometry is not made very well. It might not be. I just downloaded it from the internet somewhere. Let me just see. It might not be like closed or something, so that might be giving it some weirdness. Yeah, I have a feeling. Let's just try that. Quick way to make some watertight geometry. Hey. I mean, it's not even very interesting. I mean, that's kind of cool when it's like headphone shaped, but then it just turns into a circle almost immediately. Yeah, it's just the weird thing. The shapes just blur away so quickly. It's really tough to keep anything worthwhile from these, you know? Just a circle. All right. Well, it's pushing on 11 here on the East Coast of the United States, and I am tired. I think what I'm going to do is put a little poll on the. That's interesting. That's actually faster. You know what? That's a way to make it faster. Is doing this step actually. This step is actually really good. So if I did this for the camera, I bet you it'll be a lot faster to calculate. Because, yep. Because, okay, so just last little note here. So converting this into a VDB and then changing it back into a polygon and having it have way less faces and internal elements is faster to calculate. So that was me being stupid, basically. That this makes more sense because now we're just looking at super simple geometry that doesn't have multiple surfaces, and we're able to now get a much quicker result at this stage of things. So yeah. So now if we look at this, it's literally it's like 5 times faster. So anyways, it's a quick thing. So I'm going to put a little poll up and see, if people are interested in continuing this conversation, because I think there's certainly some more stuff to do with this, or if we go in a totally different direction or whatever. So anyways, sorry for a little bit of technical problems tonight. I had internet problems, then I had camera problems, and I don't know what's going on. Gremlins in the system. Anyways, thank you guys so much for joining me. If you are interested in checking out our Discord channel, there's a link at HoudiniHangout.com. You can check that out. Put in suggestions for things that we might show how to do on the stream. Things you've seen out there that you're like, wow, this is really cool. How the heck would you do this? And I'll hopefully try to come up with something, if I can. Won't be able to figure everything out, but yeah. So thank you guys so much for watching. Crossfader, thanks for suggesting this little setup here, and yeah, I'll see you guys next time. Thanks so much. See you later. Bye.